All right, we are on to our last video. If you've been following in order, then you'll know that I have my Apple Pencil back charged up again, so my handwriting should look good again. All right, so our last problem here, we have been given this lovely curve G, and it is a nice implicit equation, right? So that means it's not solved for y, so we're going to have to use some implicit differentiation on this one. Thankfully, they have given us the answer. We just need to show that it is that. So we are going to, in part A here, differentiate with respect to x, the function y cubed minus y squared minus y plus 1/4 x squared. And the other side we'll just differentiate it as well. So show that we're taking the derivative of both sides. And so then we'll just go from there. So the first one here is going to be 3y squared, but then we need to add in our dy dx because we're differentiating with respect to x. So we got 2y dy dx minus the derivative of y would just be 1, but don't forget that dy dx. And then here we've got, bring the 2 down, so 1/2 x, and we don't need to write dx dx, we'll just leave it at that. And the derivative of 0 is 0. So now the only thing left to do is show that that is equal to this other equation, which means that we need to do some solving. So we can factor that dy dx out, right? So in this particular problem, all the dy dx's were on the same side. We just need to move that 1/2 x to the other side. So had we had dy dx's on both sides, we would want to collect all of them over here to the left. And then we could factor out the dy dx. When we factor it out of itself, there'd be a 1 there, and then I'm going to go ahead and move that negative 1/2 x to the other side. And so then last step, just divide by the 3y squared minus 2y minus 1. And when we do, we would have negative. And then the way they wrote it was the x on the top, and then they kept the 2 on the bottom with the 3y squared minus 2y minus 1. So there it is. And we are all done with that. So hopefully that matches the answer they got, and it does, and we're moving on. Part B, there's a point P on the curve G near to -1 with an x-coordinate of 1.6. Use the line tangent to the curve at that point to approximate the y value or the y coordinate of point P. Okay, so as I'm reading that, I see I'm going to use a line tangent to the curve at this point. So that means I need to write a tangent line. So I know that in order to write a tangent line, I need a point and I need a slope. So my point was 2, -1. And then I need to know the slope there, so I can use the equation that I just got. And again, if you weren't able to get part A, you at least had the answer, so you can still use it. So that would be -2 divided by 2 times 3 -1 squared minus 2 times -1 minus 1. And I am going to go ahead and find out what this value is, just because since I'm going to need to plug that slope in. Now, the nice thing is those 2's would just cancel, right? So I'm going to have -1 over, and so this would be what, 3 plus 2, so 5 minus 1. So -1/4 is my slope. So the equation of my line is going to be y plus 1 equals my slope times x minus 2. And they wanted me to use that line to approximate the y value at 1.6. So I can come in here then and just plug 1.6 in. I am also going to go ahead and move the 1 to the other side. So I got 1.6 minus 2, and then I've got the minus 1. Now that I would just stop, right? There's absolutely no reason to simplify that. You can just leave it at that. If you did simplify it, it would be -0.9. But there's absolutely no reason to simplify that, so you're all good. One thing to mention on this part, they don't ask about it here, probably because this is an implicit curve, so it'd be a little bit harder to do. But one thing they a lot of times ask on this is your approximation an overestimate or underestimate? And so remember that you can, if they ever ask you something like that, then you would want to be thinking about the concavity, or if the function's increasing, decreasing, and think about then if that tangent line would be an over or under approximation, right? So like if you knew that it was concave down, then that tangent line, right, would have been an over approximation. Or if you know that it's concave up, then that tangent line would have been an under approximation, right? So things like that are also things they commonly ask on questions like this. All right, part C. For x values greater than 0 and y greater than 0, there is a point S on the curve G at which the line tangent to the curve at that point is vertical. All right, so find the y-coordinate of that point S and show the work that leads to your answer. So if we know that the tangent line is vertical, that means that its slope is undefined, right? So if the slope is undefined, then we know that that would happen when the denominator is equal to 0. So we can set that 2 times 3y squared minus 2y minus 1 equal to 0. And you want to write that out because you're showing that that is when that slope is undefined. If they had said it was a horizontal tangent, then we would have set the whole derivative equal to 0. So that would have just been when the top was equal to 0. But in this case, they wanted to know when it was undefined. So we can set the bottom equal to 0. And 2 would divide out. And then we just need to factor this. So when we factor it, we get, 3y and y. And then if I put the 1 over here and 1 here, so then this is going to be negative 3y and plus 1. So then we get two y values. We get when y is negative 1/3, and we also get when y is 1. But remember up here they told us that the point S is for when x is greater than 0 and y is greater than 0. So that means that we can throw out that negative solution, and our only answer is y equals 1. In this particular case, they did not need us to plug back in and get the actual point. So just read carefully. Sometimes they might want the point. If that was the case, we would need to plug back in. And remember, we would be plugging back into our original function if we needed to find the coordinate of the point S. But they just want the y coordinate of the point S, so we don't need to do that. So again, just always read carefully, see which thing they're asking for. It varies from question to question. A particle moves along the curve H, defined by the equation 2xy plus the natural log of y equals 8. At the instant when the particle is at the point 4,1, dx dt equals 3. Find dy dt at that instant. Show the work that leads to your answer. So we have an implicit differentiation again, but this time it's with respect to time. So it's like a related rates problem, right? They've given us that this particle is moving at dx dt equals 3. So that's the rate it's moving on the x direction. We need to figure out the rate it's moving at the y direction. And so we've got the equation 2xy, scroll all the way down here, 2xy plus the natural log of, I think it was y, come back up, yep, equals 8. All right. So this time when we differentiate, right, we're going to do it with respect to time. So we're going to take the derivative of this with respect to time, and we'll take the derivative of this with respect to time. Remember that point they gave us. So they gave us the point 4,1, right? We cannot plug that point in until after we differentiate. It's not a constant. Only if there was some constant could we plug in. All right, so when we differentiate, this is going to require a product rule, right? So we're going to need to use our good old product rule here. So we've got keep the 2x, the derivative of y would be dy dt, plus, I'll keep the y, but the derivative of 2x is 2 dx dt times y. Okay? And then plus the derivative of natural log of y would be 1 over y, but we need that dy dt. And the derivative of 8 is 0. So there is our derivative. And again, notice on this one, right, we had to have the dx dt and the dy dt because this time we were doing it with respect to time. So they both get that in there, right? Versus up here in that part A, right? We were taking the derivative with respect to x, so the y got the dy dx, but the x didn't need a dx dx, right? So down here, though, they both need the dt. So, and now we just need to plug in everything we know. So they gave us that the point that at the moment it was going through the point for 1, and they told us that dx dt was 3, right? One thing to pay attention to is sometimes rather than just giving you the number, it might say that it's moving horizontally, or it's increasing at a rate or decreasing at a rate. So you have to pay attention to, if it's decreasing, then you would have needed to plug in a negative there. So, okay, so we've got 2 times 4, we don't know dy dt, plus 2 times 3 times 1, plus 1 over 1, and we don't know dy dt. So we're going to have, what, 8 dy dt plus 6 plus the dy dt equals 0. So that gives us 9 dy dt's equals negative 6. So dy dt equals negative 6/9. And I know it may sound silly, but if you think you're going to mess up and accidentally write something that is not equivalent to 6/9, then I would just stop right there, okay? Because if you simplified that wrong and wrote something silly like 3/4 instead of 2/3, then they would not give you that last point. So just stop and don't simplify the fraction. All right, folks, that's all 6. Hope that helped.
Done? Done?